Okay, fifth graders, here's a little bit of homework help for you guys. I came across this, it made me smile. It says math is the only subject that counts. Do you get it? Do you get it? It's kind of funny. I liked it. Counts. It's kind of here's a college word for you. Counts. It's an equivocation. It could have two meanings. And so math is the only subject that counts. So if I was talking about cakes, I could say cheesecakes are the only kind of cakes that count. In other words, I'm saying that, all other kinds of cakes don't matter. Just cheesecakes. I love cheesecake. So if I was to say cheesecakes are the only kind of cakes that count, those are the best kind, and as far as I'm concerned, the only kind of cakes. Well, it says math is the only subject that counts. And so it has sort of a double meaning. It counts as in 1, 2, 3. Okay, never mind, I'm done. Because somebody told me once that if you have to explain a joke, it wasn't very funny. But I thought it was pretty good. Okay, so I give you guys a homework sheet here. Let's do a couple of these together. It says write each 5 through 12 here. Write each decimal as a fraction. Well, gosh, we've done plenty of these. You guys even had a quiz on it today, so I'm looking at number 5 here. It's 0.009. Write that as a fraction. How many places do you see before the decimal? 1, 2, 3. So we're going to say that's going to be 9 over 1,000ths, because it goes to the thousandths place. Let's see here. Let's go back up to number 1. Let's back up to number 1 here. Number 1, what did they tell you to do? It says, what's it say there? It says 0.08 is 10 times as great as, and then it gives you a blank. Well, gosh, let's look at this for a moment. I showed you guys this today. And this is for math. I should say this is for math class 1 and 2. This is for both my math classes. So when we're going this direction, okay, or this way, the tens are 10 times as great as the ones. And the hundreds are 10 times as great as, the tens are 10 times as great as the ones. The hundreds are 10 times as great as the tens. The thousandths are 10 times as great as the hundreds. And I can keep going here. 10 thousandths are 10 times as great as the thousandths. If we're going in this direction here, tenths is 10 times as great as hundreds. And hundredths is 10 times as great as thousandths, and thousandths is 10 times as great as 10 thousandths, because they're getting smaller as we go this way, and they're getting larger as we go this way. And so if we were going in the other direction, millionths right here, for example, is 10 times smaller than hundred thousandths. Now we're going the opposite direction. And 100 thousandths is 10 times smaller than 10 thousandths. All right, so let's go back to that question. And it's important you guys, read these questions and really think about it. It says 0.08 is 10 times as great as, so it's 10 times larger than what? 0.008. If this one's larger, then the smaller one is going to be going that direction. And 0.008 is 10 times as great as, we're going in this direction, 0.00008, which is 10 times as great as 0.00008. See where I'm going with that? All right. That was number 1. Should I do number 2? I'll do number 2 over here. Number 2, 0.002, 0.002 is 1/10 of what? So it's 1/10 of something, so it's smaller than something. It's 1/10 of something. What is that something? Well, if it's 1/10 of something, it's going to be smaller, so we'd move that way to end up with 0.002. So it's 1/10 of 0.02. All right? You guys, you could do these, think about them. Think about which way they're phrased and which way you would go to make it smaller or larger. Just remember, if you go to the left, if we're going in this direction, it's larger. If we're going in this direction, it's smaller by 1/10 or by 10 times larger. All right? Let's do, let's do number 16 here. Number 16. It's, what do we got to do? Write each fraction as a decimal. So it's 29 over 1,000. Okay, write that as a decimal. How many places are we talking about here? 3 places. Okay, so there's the decimal. What numbers do we have to work with? 29. So it's going all the way to the thousandths place. So since there's only 2 digits, though, we're going to put a 0 to 9. Now we have 3. We have tenths, hundredths, thousandths. So there's your answer for number 16, 0.029. All right. I think you guys are fine with that page. Let's look at the next one here. And I took my tablet and took a picture of the sheet. That's what we've got here. Let's see here. Number sense. Tommy, what am I looking at? Number 21 here. Tommy is beginning a science experiment in the lab, and the instructions call for 0.322 kilogram of potassium. Write 0.322 as a fraction. Okay, so I'm looking at 21 right here. 0.322, or I mean, as they've got it in the book right over there, or the sheet, it's 0.0322. Those are the same. There's no difference between those two. Write as a fraction. How many places are we talking about before the decimal? 3 places. So it's going to be something over 1,000. I'm going to put 1,000 down. And what is it? Well, it's 322. There it is, as a fraction. Done with number 21. All right, let's look at 22. It says Mount McKinley. I haven't climbed Mount McKinley. I climbed Mount Shasta when I was younger, and that was a chore. But anyways, Mount McKinley. Oh wait, is McKinley in California? No, I'm thinking of, where is McKinley? I don't remember where Mount McKinley is. I'd have to look it up. Alaska? No, is Rainier? Where's Rainier? Oh, I'm getting my mountains. Anyways, I know I climbed Shasta when I was younger. Anyways, Mount McKinley is the highest mountain peak in North America with an elevation of just over 20,000 feet, 20,320 feet. What is the value of digit 3 in that standard number? So what number are we talking about here? 20,320. What's the value of digit 3? Well, what is its value? That's easy. 300. All right. Let's see here. This is one. I had my book open in the wrong one. This is the right. Yeah, that's the right homework. I wasn't sure if I gave you guys the right homework at first or not. For a second there. So let's look at 23. Construct arguments. Let's see here. Is that pronounced George? I guess George said that 0.029 can be written as 29 over 100. Is he correct? Well, no, he's not correct. This is number 23. 0.029. And he said it can be written as 29 over 100. Is that correct? Well, the answer is no. He's not correct. Why? Well, first off, this goes all the way to the thousandths place. Tenths, hundredths, thousandths. And this is 29 over 100. So is he correct? No. Because 0.029 goes to the thousandths place, and 29 over 100 is only in the hundredths place. Okay, forgive my sloppy writing. All right, that was 23. So let's look at 20. How about 26 here? Write the fractions. What do we got here? We got 5 over 10. We got 5 over 100. And 5 over 1,000. How are the decimals related? So let's write them as decimals. Well, what's this one going to be? This is going to be 0.5. Okay. What's this one going to be? This is going to be 0.05. And what's this one going to be? 0.005. 3 places, goes all the way to the thousandths. Okay. And the question, back to the question here, it says, how are the decimals related? Write them as decimals. How are the decimals related? That's kind of worded very poorly. When they say decimals, I think they're talking about the number, the decimal number. So 0.5, this one here, how are they related? There's a couple different ways you could do this. Let's see, I'm running out of room here. Let me move up. Oh. Okay, there we go. So they don't give you much room to write this. 0.5 is 10 times larger than 0.05, which is 10 times larger than what? 0.005, which is 10 times larger than 0.0005, which is 10 times larger than 0.00005. That's one way you could answer that. There's probably more than one way. Okay. All right. Let's see here. Should I help you guys with one more? I don't think so. I should probably end the video here. You could do 27. Let's see, 28. In 3 months, Harold watched a total of 40 movies. Holy cow. I must be, watching movies on TV or something. I was going to say that guy needs to get a life. If he watched 12 movies in June and 13 movies in July, how many movies did he watch in August? Oh, well, that's easy. I think you guys can do that one. 12 movies in 1 month, 13 movies in another month. What's left over? Okay. Then it says write an equation using the variable a to model your work. Oh, so 28 is 28. Okay. So let me show you guys something. This is kind of important. Gosh, this is the first we're touching on algebra here. Algebra is when we start putting letters in equations. Don't panic. It's okay. Don't panic. Letters just simply represent a number that you don't know what it is. So if I wrote something like 3 plus C equals 5, what do you think C is? C simply represents 2. So then it says write an equation using the variable a, and a variable is any letter. They just happen to pick A. In this case, it was C. To model your work. So it'd be 12 plus, what was the other month? 13. 12 plus 13, okay. Plus, what's the number we don't know? That's A. Okay. Where is it here? There it is. A equals what? How many total movies did he watch? 40. There's your equation. 12 plus 13 plus A equals 40. Well, I think you guys could figure out what A is, but they don't even ask you that, do they? Oh, they do. It says, how many movies did he watch in August? So A represents how many movies he watched in August. So give me the answer to that, what A is. A equals something. And then it says write an equation using the variable A to model your work. And there's the equation. I just gave that to you guys. Okay, awesome. Wow, you guys are touching on some algebra already, all the way back in 5th grade. Okay, that's it. I will talk to you guys later. See you Monday.